velocity is basically a measurement of how fast something is moving. We have average velocity and we have instantaneous velocity. We're going to start our topic today with average velocity. And we'll go back to our first example with the car at the starting line at 0 meters traveling down the racetrack at 400 meters. Okay, when we say average velocity, and this is V for velocity and AVG for average, and remember we're traveling down the x-axis, so I'm going to put a subscript of an x too, and that defines the average velocity in the x direction. And we'll define this as the change in x, or the displacement in x, times the change in t, or the change in time. So average velocity is the displacement, or the change in position, divided by the change in time. So you see here that not only do we need to know the initial and final position, we also need to know the initial and final time. If we write this out, it becomes apparent. x2 minus x1 divided by t2 minus t1. So we need to know the initial and final time. So for this example, let's say the car travels down the 400-meter racetrack and it takes 8 seconds to get there. So we'll say that as soon as the race starts, we look at our stopwatch and it says 0 seconds, and we hit start. And so at that point is our T1. So 0 seconds, or 0s for seconds. And the race car travels straight down the racetrack on the x direction, and when it hits the finish line, we hit our stopwatch and we look down and the stopwatch says 8 seconds. So T2 is equal to 8 seconds. And so our average velocity would just be plugging into this equation. x2 minus x1, which is 400 minus 0, or 400 meters. And we have t2 minus t1. t2 is 8 seconds. t1 is 0 seconds. So that's 8 seconds. So 400 divided by 8 is 50. And that's meters per second. That's the units. So that's important to realize that the units on velocity are meters per second, or a distance measurement divided by a time measurement. Now for our cars, we usually say that it's in miles per hour. Again, that's distance over time, miles over hours. In this case, we just used meters per second. And meters is a common unit that we use in physics, so you should get in the habit of using meters. Feet per second, we can also describe the velocity in, but it's somewhat common, but not as common as meters per second. Okay, so this is our V average in the x direction. Okay, we can take this a step further and do the same thing we did last time. Let's say we want to know the average velocity between line 1 at x1, so we'll have to redefine our variables here. And we want to know its average velocity between these two lines, x1 and x2. Okay, so this will all have to change. And we'll say again that x1 is 100 meters from the starting line, and the second line is 300 meters from the starting line. Okay, so let's say the starting gun starts and we hit our stopwatch again, and the car travels straight down the straight racetrack, and when we look down at our stopwatch, when it hits the first line, we see that our stopwatch says 3 seconds. So T1 would be 3 seconds. And the car keeps traveling and keeps traveling, and when it hits the second line, we look down at our stopwatch again, and it says 7 seconds. So T2 in this case would be 7 seconds. So again, we plug this into our V average equation. Here, x2 minus x1 is 300 minus 100. So that's 200 meters it's traveled between those two lines. And T2 minus T1 is 7 seconds minus 3 seconds, or 4 seconds. If you divide that out, you get 50 meters per second. Okay, so the average velocity of the car between line 1 and line 2 was 50 meters per second again. And you notice that the average velocity only depends again on the initial and final position. When we did our previous example, the initial final position was 0 and 400, and this time it was 100 and 300. And it also depends on the initial and final time. We're not saying anything about the car's travel between the 2 points where we take our calculation. So this car, between these 2 lines, it could have sped up really quick and then slowed down to get to the second line. It could have been really slow at first and sped up really quick there at the end to get to the second line. We don't know what it was doing between those 2 lines. All we know that on average, it was traveling at 50 meters per second. So if we look down at the car and we wanted to know what the car's velocity was at this point on the track, we can't tell you that. We just know the average velocity. So that brings us into our next topic, and that's instantaneous velocity. Instantaneous velocity is basically the velocity of an object at a given instant in time. So a good example of this is, say you're traveling down the road in your car, and you look down at your speedometer, and the speedometer reads 60 miles an hour. Well, that moment, the instant that you looked at your speedometer, you were traveling 60 miles an hour. That's your instantaneous velocity. It's that simple. So let's try and explain it in terms that we've been talking already today. So we'll define it as Vx. We'll drop the average, and it's actually defined the same as average velocity, your delta x over your delta t, but it's as your delta t gets small. And I'll explain this in a second here. So let's say, for example, we wanted to find the instantaneous velocity of the car at the first line. We want to know exactly how fast it was traveling at 100 meters. And to do this, we are saying that we need to get delta t to be very, very small. So in our original case, our delta t was 7 seconds minus 3 seconds, which was 4 seconds. So if we get our delta t very, very small, our t2 and our x2 has to start getting really, really close to our first position. So our second line, instead of being all the way out here, is going to be really close to line 1. Okay? And that will satisfy our delta t getting small. And so if that's the case, we've only allowed the car to travel for, let's say 0.1 second. So our new t2 would be 3.1 seconds, because we hit the first line at 3 seconds, and we look down at our stopwatch 0.1 seconds later, and it says 3.1 seconds. So now we've satisfied that, the delta t getting really, really small. And since the delta t is really, really small, our delta x has to get small. Let's say that the car could only travel 3 more meters after this 0.1 second time interval. And so x2, our new x2, at this second line, would be 103 meters. Okay? And you can kind of look at this as calculating the average velocity in a very, very small time frame, in a very, very small position. Like in this case, our average velocity was calculated over this long distance. But in this case, our average velocity is only calculated along a very, very small distance. And so it gives us a more accurate reading. And we call this our instantaneous velocity reading. So let's do this calculation. Our delta x is now x2, which is 103 meters, minus x1, which is 100 meters. Okay? And our delta t is 3.1 seconds minus 3 seconds. So this is 3 meters divided by 0.1 second, or a velocity of 30 meters per second. So at the moment that this car hit the first line, it was traveling about 30 meters per second. Or again, another way you can look at it is its average velocity between 100 meters and 103 meters was 30 meters per second. And that's instantaneous velocity. Okay, before we move on, I want to talk about the difference between velocity and speed. Now, we've been talking about velocity this whole time, and we've defined it as how fast something is moving, and we've also been talking about in which direction it's moving. And so velocity, to put that more clearly, velocity is how fast an object is moving, in this case 30 meters per second, and in what direction it's moving. And we've said that the car is moving in the positive x direction, right? Now speed only tells us how fast something is moving. It doesn't give us an indication of what direction it's moving. So this car, if I told you that it was moving 30 meters per second, it could have been moving this way, it could have been moving down, or it could have been moving down, it could have been moving up. We wouldn't know if I just said the car was moving 30 meters per second. And so that's an important concept to remember. Velocity is how fast something is moving and in which direction it's moving. And speed is only how fast something is moving.